Hi students, I'm going to take you on a whistle-stop tour through the research offering of our GMT section of civil engineering. You will virtually meet the different leaders and researchers, and they will talk about the activities related to their research. As you can see from this slide, we cover a diversity of different subjects. Let's begin with pavement engineering. So representing pavement engineering is myself, Kim Jenkins, and my colleague Elaine Goosen, and we'll be sharing our info with you. We deal with a plethora of different materials and types of analysis that we use in our research. Let's use this slide as a template to explain our research. So we've got materials and modeling of materials. We've got pavement design, and then we've also got maintenance and construction, also very important. Beginning with materials, we work with blasted aggregates, crushed concrete and masonry, secondary materials, recycled materials. More and more are becoming a part of our roads. In addition, we look for the most optimal ways of using recycled asphalt that's old and milled off the road. When it comes to research, innovation is extremely important, but also that golden thread of sustainability, considering environment, social aspects, as well as the economic. We look at green binders where we don't use fossil fuels and find environmentally friendly type of binder, as well as measuring energy and emissions, because these are extremely important to optimize and to have the minimum impact on the environment. And then finally, in those innovative materials, we've got all sorts of polymers and nano products that can give us special performance that we need to research. Advanced research obviously requires advanced apparatus and equipment, and that's what you can see on this slide. Lots to play with. Globally, there are about 20 million kilometers of road infrastructure. We are challenged to find cost-effective and sustainable and durable solutions to our roads. If you look at the video, you will see in situ recycling. We need to look carefully at the binders and the most effective way of doing the recycling. In addition, a project that is using 100% of the reclaimed asphalt, the old milled asphalt, and repaving it as a base layer. Quality data provides quality research. Here is a PhD research project that shows a thin layer that is modeled with finite elements on a deeper pavement structure. And finally, we're housed now in a new pavement laboratory, which actually covers transport, geotech, and pavement engineering all in one building. So it's a fantastic environment to work in. You're welcome to come and join us, and I'm going to hand you on.
So why should you do a master's degree in transportation engineering? There are at least three answers to the question. First of all, I know that many of you are passionate about making a difference in the lives of normal South Africans. And transportation is the one area of civil engineering that you can be guaranteed of making improvements in how people are able to get around and how they experience the quality of their life here. Secondly, transportation is the only branch of civil engineering that is going through an extraordinary revolution. We expect that in 30 to 40 years, our transport networks will look completely different, with autonomous mobility, connected vehicles coming on board, huge advances in technology, making it possible for us to rethink the way that we have always considered our transport options in the past. And thirdly, in spite of the technology that we have at our disposal, we still have major intransigent problems in our society, including high numbers of road deaths every year, and so making a difference to the design of our roads to minimize human error on our roads is going to save people's lives in the future. So 3 good reasons. Let's have a look at our current offerings. So there are 3 of us in the Transport Department at the moment, Mrs. Megan Brever, Prof. Johanna Anderson, and myself. We're also looking to expand our mobility lab to become a centre for smart transport in South Africa. There's a huge gap in that area at the moment and a huge demand for much better skilled engineers in the transportation community. Our offerings include the conventional traffic engineering and transport planning, which is led by Mrs. Brever, and this relates to research related to the design of transport infrastructure and the planning of transport systems, both private and public. Intelligent Transportation Systems is offered by Professor Anderson, and this involves application of data analysis, communications, and information technologies to transportation to improve level of service, mobility, and efficiency, including connected or autonomous vehicles, the smart city concept, mobility as a service, and increasingly across all 3 of our areas, the use of big data. And then finally, my area is road safety, and here we work to understand and prevent crashes across the country, looking at road, vehicle, and human factors. Across our transportation division, there are connections with international research organizations and other universities and opportunities for exchange programs. There are bursaries available. If you're interested, please contact us. Transportation engineering is not just about designing the system, it's about understanding the relationship between the system and the human user of that system. And if you are interested at all in people and in embracing technology, transportation engineering is the field that you should be in.
Hello, my name is Charles McRobert, and I am the discipline head for Geotechnical Engineering here at Stellenbosch University. And this short video is just to discuss some of the postgraduate options that are available. And rather than you seeing my face, I will let the geotechnical engineering speak for itself. So I'm going to bring up a picture of one of the bridges that's being constructed as part of the N2 Wild Coast project. Now this may look like a very impressive structural engineering feat, but if we actually look at what's been built at the moment, what has been built at the moment are the foundations for this one-day fantastic bridge. And this is probably some of the most complex geotechnical engineering that is underway in South Africa at present. And I guess this is the reason why I love geotechnical engineering. And I find it a really fascinating field as it deals with the ground, and the ground is complex, which makes it difficult to quantify, to figure out exactly what its engineering behavior is. And so a good engineer or geotechnical engineer needs to be able to balance both the art and science of practice. And that is why you will never be bored as a geotechnical engineer. So what are some of the options available for postgraduate study in geotechnical engineering? Well, we offer what's called a postgraduate diploma in engineering, and this is a modules-based postgraduate degree. Then there is the Masters of Engineering, and there are 2 approaches here, a structured and a research. The structured approach, you do 8 modules, and then you do a small research component, whereas the research one, you have a much larger research component. So you still need to do 3 courses, but your credits come from doing a research project. And then obviously there is the PhD, and there's also a doctorate of engineering, and this is purely based on research. So having a look at the modules, so for both the PDE and the structured Masters of Engineering, you would do 8 different courses, and there are 5 courses which are related to geotechnical engineering. So there is foundation engineering, which looks at the practical aspects of designing spread footings and piled foundations. Then there is soil behavior, which looks very closely at the particulate nature of soils and how the different minerals combine to form a fabric, which dictates how soil behaves under load. Then there is applied geomechanics, which looks at how to determine appropriate strength parameters for the analysis of slope stability. And this particular course is offered fully online. Advanced Geotechnics, which looks at how to use statistics to determine how likely a structure is to fail, considering the uncertainty in the parameters and our understanding of the problem. And then pavement materials, which is offered by the pavement section. And this particular course deals with the granular soils that are used to make up our roads. So this is um, got a lot of fundamentals that are in tandem with geotechnical engineering. And then there are 3 general engineering topics that you also need to do to make up your 8 modules. So data analytics, numerical methods, and project management. So that would form your curriculum if you did the PDE or MEng structured. And if you did the MEng structured, in addition to these courses, you would also need to do a small research project. So for your research project, there are 3 academic staff who would be able to supervise your work. There's myself, and Charles McRobert, and my research interests lie in global stability and seepage assessments. So preventing slope failures, and with tailings dams, looking at where the seepage is going. And then obviously to model, we need to be able to characterize. So the characterization of the material parameters, particularly using dynamic in situ tests. And then another area of research that I am interested in is judgment and decision making. So as I mentioned, in geotechnical engineering, there's a lot of variability, and often we sample less than 1% of the actual material that we will be building or building on. And so there's a lot of epistemic uncertainty that has to be analyzed using judgment. And then at the end of the day, as engineers, we are decision makers. So how do we convert all that information into a decision? Then there's also Dr. Nene Fouchier, and her areas of research are geotechnical characterization, in situ testing, problem soils, geotechnical earthquake engineering. And a particular focus of her research is the Cape Flats. So the Cape Flats sands cover most of the area between, I guess, not really Stellenbosch, but from Stellenbosch all the way to Cape Town, are where the Cape Flats lie. And understanding these soils is very important for the development of the Western Cape, or the Cape City Metro. And so that's where a lot of her research effort is placed. And then the third member of the academic staff here at Stellenbosch is Leon Krokamp. And his research interests are quite wide and varied and very interesting. So the application of drone technology in geotechnics. And then at the moment, he has a research project looking at using drones to look at ballast on railways. So ballast is a granular material and it falls under geotechnics. So that's a very interesting research project that he's involved with. Obviously, the laboratory analysis to characterize soil parameters. So how do we use triaxial tests, direct shear box, odometer, and all the other various tests in the lab to characterize the material. And then very interesting, lunar geotechnical parameters. So looking at the soil on the moon, and I guess extending that also to Mars. So there's a lot of research going on at present, particularly on Mars, looking at the parameters, and then also lunar. So how do we actually establish a base on the moon? We would have to build foundations. We'd have to support structures. Maybe we can use the material on the moon to build those structures. And then cemetery and waste disposal sitting. So where do we put these facilities? Geotechnical investigations for those. And then another one is geothermal potential. So the ground can be a source of energy. So in South Africa, geothermal energy is not really utilized a lot. So maybe this is something that can be explored. So investigating these potential sites to see what type of energy can be extracted. So that brings me to the end of this brief presentation, and hopefully I have captured your imagination, and that you will consider coming to us to do a postgraduate degree in geotechnical engineering, and that will enable you to embark on a very interesting career in a field that is ever changing. Thank you for your time.
My name is Jan William, and together with my colleague Chris Jurgens, we are responsible for the postgraduate program in construction engineering and management. With this brief overview, we are going to give you an introduction to our field of expertise. In construction engineering and management, we consider all aspects for the successful realization, execution, and maintenance of construction projects. And that includes all parties that participate in a project. Our postgraduate offering includes the Master's Research and PhD program. For the Master's, we accept students for full-time study, and in exceptional cases, also a small number of part-time students. At present, we do not have bursaries, but we continue to explore opportunities at industry and other sponsors. My areas of research include constructability in construction, prefabrication, construction risks, quality management and rework, and in all of these, we aim to make use of building information models as part of the research.
Good day, ladies and gentlemen. My name is Chris Jurgens, and I look forward to seeing all of you in Engineering Management 454, as well as hopefully for Master's Studies someday, where we are going to look at some really interesting things, such as large construction drones, as well as other technology and green engineering related topics. Let's have a quick look at them now.
My research primarily focuses on technology in construction, where we look at the application of drones in the construction industry, 3D printing of structures and houses, low-cost hardware in construction, big data, and machine learning. On the green engineering side of things, we focus on renewable energy projects and the implementation thereof. We look at sustainable building materials, green roofs, and green public spaces.
So it boils down to three options. You can go it alone and probably come off with more than a headache. The second option is to sidestep the challenges and be left in a cloud of dust. And finally, you can align yourself with the right partner and come out with a successful solution. So it's up to you to decide.